All right, good morning. Well, we had a few little technical problems getting spun up today, but sometimes the bit bucket gets full and the bits overfloweth. And when they overflow, they fall on the floor and you can't pick them back up again. But now we've got that bucket bigger and we're off moving forward with the day 2 of the 58th annual Goddard Symposium. Today, our theme is planetary stewardship. My name is Alan DeLuna. I am the president of the American Astronautical Society. And on behalf of the Society, we thank you very much for participating in this event. So thanks to all of our event sponsors, Aerojet Rocketdyne, the Aerospace Corporation, Ball Aerospace, Blue Origin, JHU APL, KBR, L3 Harris, Lockheed Martin, Northrop Grumman, SAIC, Teledyne Brown Engineering, and our media sponsor, Space News. We want to thank L3 Harris, who is our student sponsor. They're sponsoring 10 student registrations for this event. We have between 20 and 30, I think 20 something yesterday, maybe a couple more today. So we have a fairly strong student participation. And we want to thank everybody at the NASA Goddard Space Flight Center for supporting this and being our host. And I'd like to thank our planning committee, which is shown here. There they are. All right, so yesterday we went from A to Z. And the A to Z was Andresic to Zurbuchen. We got everything from the center stuff to program stuff to worldwide stuff, deep science and medium level science, and some operations as we went through that. Today we have a different agenda. I think you'll find it interesting and valuable. But first I want to talk a little bit about today's significance. Today, 60 years ago, is the reason that I'm sitting here. It's a little strange to think that far back, but it's true. Back at 9:34 Eastern Time, on May 5th, 1961, I was sitting in my living room in Weaver, Alabama, watching the launch of Alan Shepard. Alan launched at 9:34 Eastern Time on that date. And I immediately got my little erector set, my toy erector set, and built for myself a kid's version of the control panel that I saw on the pictures of the Freedom 7 capsule. And I kept that for several years until my mother got tired of having it sit in the middle of the floor and took it apart and threw away some of the pieces. But 60 years ago was the launch of Alan Shepard. If you get the opportunity to look at some of his life history, you'll see he was an overcomer. He overcame lots of challenges. And if you look at some of the history of that countdown, you'll see where some of the things that he experienced in that countdown took us all the way to shuttle. One of the first things that I learned in shuttle when I was in charge of part of the launch countdown was that you did not keep the astronauts on their back more than 3 hours. And a lot of that goes back to the Alan Shepard experiences. So anyway, back to today. Some logistical items. We'll have a break of 20 to 30 minutes each day for you to get some lunch or for us to pee, one or the other. And we do have a Q&A tool on your screen. You'll see a Q&A. You can click on that and give questions for our speakers. Your questions should not be longer than a sentence or two, else they become speeches. If you're using Twitter or other social media, our hashtag is #Goddard2021. Again, that's number or # Goddard2021. You can follow us online on Facebook, Twitter, and Instagram. And finally, our session intros will be extremely short, maybe non-existent, so that you'll have time for discussion and Q&A. The full bios of all of our speakers and panelists are available in the interactive program. So at this time, we have a little short video for you. And I'm sitting here looking pretty for the camera. We're waiting for the video.
At Lockheed Martin, our why is found in connecting, protecting, and exploring. It propels our purpose from the moon to distant planets and the stars beyond. We've been a part of every NASA sample return mission, every NASA Mars mission, and we are building the spacecraft that will carry humans to the moon and on to Mars. At Lockheed Martin, Your mission is ours.
All right, so let's get started with our keynote talk. To introduce our speaker, please welcome Lisa Callahan. She is the Vice President and General Manager, Commercial and Civil Space at the Lockheed Martin Corporation. Lisa, take it away, please.
Thank you, Alan. It's my pleasure to introduce our Day 2 keynote speaker, Dr. Gavin Schmidt, Acting Senior Climate Advisor at NASA headquarters and Director of NASA's Goddard Institute for Space Studies. Dr. Schmidt's research works to understand the impact of climate drivers and the uses of space-based observations to refine our climate models. He's a recognized leader in the field of climate change research and has led the development of the Goddard Institute Earth System Model. One of the keys to tackling climate change is to effectively communicate its threat and opportunities. And Dr. Schmidt has been one of the most effective voices in describing the nature of climate change, how the scientific community achieves consensus, and what needs to be done to further study and mitigate climate change. He started the Real Climate website in 2004 and made climate science accessible to the general public. In 2011, he was awarded the first ever Climate Communicator Prize given by the National Geophysical Union. NASA is a crucial resource in studying our planet with the vantage point that space provides, and Dr. Schmidt's in a position to accelerate the work as the drivers of climate change continue and compound one another. NASA's Earth Science mission covers the entire globe, making it a research not just for the nation, but for the world. We see the impacts of climate change across our planet. My team at Lockheed Martin builds the GOES-R geostationary weather satellite in partnership with NASA and NOAA. We have observed an increase in cadence and severity of extreme weather events. In fact, in 2020, we broke a record for billion-dollar natural disasters, with a total of 22 disasters costing $1 billion or more in the United States. We're also the proud partner with the Oklahoma University and NASA in building the Geostationary Carbon Monitoring Observator, or GeoCarb. It was great to hear from the mission's principal investigator, Dr. Berrien Moore, during yesterday's session. This NASA climate investment is going to provide vital measurements of greenhouse gases across the Americas that will help us to better understand our planet's carbon cycle in unprecedented detail and give decision makers new data needed to address this urgent global climate challenge. With this background and context, Dr. Schmidt, we appreciate you kicking off today's conference session on this important topic. I'll now hand it over to our keynote speaker, Dr. Gavin Schmidt.
Thank you very much, Lisa. Can you hear me? Great. Well, I will anticipate my slides coming up at some point. There we go. Okay, great. Well, I'm going to talk about NASA's climate strategy, and let me caveat this right at the beginning. This is very much a work in progress, and it is quite an as yet a personal view of this. Hopefully, that will firm up in time. But I thought that this would be a great opportunity to talk about what NASA is doing in climate and how we're thinking about ways to improve that and to make it a little more coherent. Next slide, please. So we know that the NASA is mandated to do a whole bunch of things. You can click through the text. Yep, that's good. We're mandated to work on aeronautics and improve the efficiency of the nation's air transport while protecting the environment. We're mandated to research topics that can be productively studied from space, including Earth science, of course. And we're also told that we must pursue a program of Earth observations, research and applications to better understand the Earth, how it supports life, and how human activities affect its ability to do so in the future. one of the interesting things about the law is that one of the metrics that we are mandated to use is that whether our science and our work has practical benefits for society, and that always has to be an important measure of our success, in addition to the mere securing of new knowledge. It's not mere, but the securing of new knowledge, and this is by far the least thing. We are mandated to ensure the availability and widest possible use of accurate and current data on global warming specifically, but on Earth science more generally. And so it's very clear that NASA is mandated to have a role in climate change, in the observations, in its understanding, and in the activities that can make a practical benefit for society into the future. Next slide, please. This is kind of my other caveat. I am really just starting to get a hold of NASA's full portfolio, and it's vast, and we do an awful lot of great stuff, and I cannot do it justice in a single presentation or even a single white paper or anything. So if I've missed something that you think is vitally important, I am very much in the market for more information right now. So just email me, and we'll include it in the next iteration of this. Next slide, please. So there are a number of pillars to NASA's work in climate, and the first pillar and the most important is based on observations. Next. We currently have 23 satellites and instruments around the Earth measuring climate-related things, so pointing down. There's a couple, most of them are in low Earth orbit, a few of them are at Lagrange point 1 with the Discover instrument. Most are quite large satellites, and a few are CubeSats, and we have a number of instruments on the International Space Station as well. And the sum total of things that we're measuring here covers the gamut from sea level to visual imagery, to ozone, to reflectivity, to clouds, to radiation, almost everything that you might be interested in. Next. And the context for the measurements that we're making right now are kind of captured by this graph here. This is a graph of temperatures across the Earth's surface since the late 19th century. And you can see that this is 4 different independent methods of collating that data from weather stations and ocean buoys and ship measurements. And what you can see is that climate has warmed by about 1.2 degrees Celsius, more than 2 degrees Fahrenheit, since the beginning of the late 19th century, and since the 1970s has been on a pretty steady and quite worrisome upward climb. This is what we know is happening, and everything that we see from space is really, you have to take this longer context into account. Next. But to give you a sense of whether the planet itself notices a couple of degrees here or there, the answer is yes. This is the Columbia Glacier in Alaska, a photograph taken or imagery taken from Landsat in 1989, and click. That's what it looks like in 2019. And so there's been a massive retreat of this particular glacier, but it really isn't special to this glacier. I could have gone anywhere where there is ice and you would see similar levels of retreat, whether it was in the Rockies or in the Alps or in the Andes or in the Himalayas. We are seeing this pattern everywhere on land. Next. We're seeing changes in sea ice as well. So this is the floating ice in the Arctic. September sea ice, which is the minimum, has decreased by 40% or more since the 1980s. And you can see that vast areas of the Arctic are now ice-free in the summertime compared to what they were even 30 or 40 years ago. Next. More worryingly, the gravity measurements that come from the Grace satellites have demonstrated that we're losing mass on the big ice sheets, particularly in Greenland, 280 gigatons per year of ice loss, and in Antarctica, 150 gigatons per year of ice loss. These are big numbers, and they're already contributing to rises in sea level. Next. Those rises in sea level are also being independently viewed from NASA satellites in conjunction with our partners, and you can see there's been 5 satellite altimeters in orbit over the last 30 so years, and they are measuring the rate of change of sea level, roughly 9 centimeters just in that short period, and you can see perhaps a little hint of acceleration in that data, and there is clear acceleration in sea level rise if you go back to say with the situation in the 19th century. Next. The second pillar, and I just gave you a hint of the observations that we're taking. The second pillar, though, is modeling. That's the tool that allows us to understand what is happening and why. Next. Climate models need a lot of work, and there are, as you can see with this diagram, it's a bit of not a circular development process, but it is a process that is never ending. Click. So you need model inputs, which we're also providing from satellite data. Things like where the land is, what's on the land, what the topography is, where our emissions are coming from. Many of those things are being informed by the satellite observations that we're making. Next. We use the processes that we're that we can observe from orbit, whether it's related to rainfall or cloud formation or sea ice reflectance. Those kinds of processes get encapsulated in what are called parameterizations. Those are embedded within the model, and then we end up with a model that has a few degrees of freedom, and then we can calibrate it. Click. To the best observations that we have. Next, please. Of the globe, and we're using sophisticated machine learning techniques to do the best job that we can to calibrate the models that we are building to the Earth system as it is today. And next. And then we spend a lot of time evaluating them to see where they go wrong, where they are robust, where there is still issues. And then we change the inputs, we improve the parameterizations, and do the whole thing again. So the development of climate models is very much a continuous process of improvement, evolution, and better simulations. These aren't the only kinds of models we work on. Next. We also work on weather forecast and reanalysis models, where instead of trying to calculate things a priori, we do that, but then we bring in the observed data that we can find, and then we end up with models that are as coherent to the current weather state as they can be, but then we can also fill in some of the other things that are going on. For instance, these aerosols that you see in this simulation that are being carried by the atmospheric circulation, and we can track things like sulfate pollution, sea salt, smoke, dust, and other pollutants in the atmosphere. Next. And we can use these models to predict things going forward. These are some predictions for global mean temperatures using the GISS model going out to 2100 under different kinds of assumptions. And you can see there's a whole range of different assumptions. Right at the top, SSP 585 is effectively a burn it all scenario where we find all of the hydrocarbons that we can and we burn it all. And that demonstrates that it's within our power to warm the climate more than the difference between the last ice age and the pre-industrial, which is really quite a remarkable potential. Slightly more comforting though, the lower ones there, SSP 2.6, is a scenario that is consistent with emission cuts in line with the Paris Agreement goals. Those are quite ambitious, and so one might imagine that the real world is going to lie somewhere between those lines, and I think we'll be happier, speaking personally, if it was on the lower end of those temperature changes. But it's key to looking at the future that you need to have models, and you need to have models that are fully informed with the observations that we have for today. Next. The third pillar of NASA's role in climate relates to technology. NASA is a preeminent agency in terms of building new technology and deploying new technology. So the fire engines outside decided to, okay. So next slide, please. One of the key technology innovations that NASA is working on with respect to climate change is working in the field of sustainable aviation. The Aeronautics Division at NASA is committed to building technologies and management solutions that are both global, sustainable, and transformative. Next. That involves new technology to build more efficient aircraft. Next. It involves new fuels that are not carbon-based, or that don't have to be carbon-based, so that we can fly without emitting carbon dioxide. And next. And working on operations and infrastructure so that we can optimize the use of ground control and flight paths to minimize the amount of energy that's being used. And all of those approaches are being worked on, and we will have some demonstration flights with the X-57 perhaps towards the end of this year or early next year, that would be all electric flight, that would really be a large breakthrough in how we could move forward with aviation. Next. We're also working on various space technologies that have implications for either clean energy, environmental monitoring, or even carbon dioxide removal. We are working in partnership with the DOE on small nuclear reactors. We are working in partnership with private companies to use for aerosol sensors that can be used on the International Space Station as well as on Earth. And we're working on carbon dioxide removal technologies that we need for sustained habitation in space, but also something that we may be needing here on Earth as well. And we've used many different methods to do that. We've used prizes and grants and interagency agreements, including a green flight challenge in 2011, which was open to all to see how far one could fly on a very limited amount of fuel. And those partnerships are ongoing and very, very broad and very, very deep. Next. And that brings us to the fourth pillar, which is the partnerships that NASA has built and is building with a whole suite of different groups. Next slide, please. So this ranges from the GLOBE process, or the GLOBE organization, or Surveyor, which is working with NASA and USAID in dozens of countries around the world, with people like the Robert Wood Johnson Foundation, who have sponsored and co-sponsored prize competitions for environmental technology. It's working with groups like the Gulf of Maine Research Institute on outreach and engagement with decision makers around climate change issues. It's working with our national partners, the ESA and JAXA, on the technology that we're flying in space, and dealing with the data that is coming down from there in ways that are collaborative and take the best of all the different sources of data that are coming down. We work on helping people make predictions of weather and wind, so that they can regulate and manage their energy resources more effectively. We're working with the C40 global cities to make sure that they have the data that they need to make the decisions that they're making with respect to climate change in their regions. One example is working with the New York City panel on climate change, where direct input from NASA in terms of personnel and data has had a manifest impact on the regulations and the standards that the New York City City Council has promulgated and put into law. And so we have many different levels of engagement, and we're always looking for more. Next. But NASA as a whole is an institution, and institutions with assets and infrastructure have to be worried about resilience to climate change. Next slide, please. And it turns out that for good reasons, NASA's facilities are actually quite vulnerable. I mean, there are reasons why Kennedy Space Flight Center is on the coast, similarly for Wallops, but these are places that are vulnerable to sea level rise, nuisance flooding, and storm surges. And so thinking about how those facilities are going to be changed or affected by increases in sea level is one of the things that we're very concerned with. Some of the other centers are threatened by wildfires. This photograph in the corner here is wildfires on the hills just above JPL in 2007, I think. And severe storms. So you can see this is the VAB at Kennedy after Hurricane Francis did some serious damage to those buildings. We have to both be aware of what those vulnerabilities to NASA infrastructure is, and also be aware of ways that we can make them more resilient. Next, please. And as an institution, we have to worry about our own footprint, our own emissions and impacts on the environment. Next, please. We keep track of, and have done since 2008, emissions that come about through our standard operations. So this is the buildings, electricity use, heating, on-site vehicles, and the like. And you can see that we're doing quite well in terms of reducing emissions from that 2008 baseline. We are around 38%, using 38% less electricity, roughly, than we were 10 years ago. But mostly this is because of like kind of standard upgrades of facilities, changing out light bulbs, rebuilding better insulated buildings, buying better appliances and the like. And for this to go down much further, we need to think about other ways of reducing our institutional footprint. And it turns out that NASA has a waiver in terms of reporting these things. So this doesn't include the energy used during rocket launches. And it doesn't include, how people commute and things. So there's some work that we need to do to really assess these things. But we are working to reduce NASA's footprint. And we're using things like the NASA at Work campaign to actually get crowdsourced ideas for how to reduce energy and for how to reduce NASA's impact on the environment. Next. So what are we actually doing to pull these things together? Well, I'm running a group that's called the Climate Strategy Working Group. We have brought in folks from all of the directorates, from aeronautics, from environmental management, from science, from international affairs. We brought in people from the different centers. JPL, Goddard, Langley, and we're trying to bring everybody together to really assess what it is that we're doing. And every day I'm learning more about what NASA is doing in the climate space and who we're doing it with. And as we do that, we're looking very closely at what the potential for improvements and for a greater uptake of the expertise and the information that NASA can provide to new partners and new projects. And the idea of this working group is that we're going to recommend some actions for the agency going forward and the new administrator. But we're very much at the beginning of this. And so if there's anybody out there who has thoughts about what it is that we could be doing, we are totally welcoming further input from other folk. Next. And that's it. Yeah, I mean, this is a view of NASA's climate strategy, and as I said at the beginning, it's evolving. It's large and it's an unruly beast at the moment, and we're trying to make a slightly more coherent thing of it. But I'll be happy to take any questions, or you can email me with any thoughts that you have on that particular topic. Thank you very much.
Gavin, thank you very much. We do have a raft of questions that we could ask you, but I'm going to bracket all the questions in both ends a little bit. A little bit of a question about eating your lunch, sort of. You showed that there's lots of work being done within different areas of NASA on climate change, and you're still putting together that picture. Where or when or both of those could people come in and see the breadth of the work that's being done with NASA? So that's the beginning of the question. Right. And then the end of the question is, when does this end up eating your lunch? There is so much work to do. When do your efforts become so dispersed that you're not going to be able to be effective?
Right. So that's a great question, and the fact that you don't know the answer is part of our challenge. We don't really have a one-stop shop for climate-related things at the highest level on the NASA websites or anything. There's a lot there, but it's a little bit dispersed. I mean, if you want data, then climate.nasa.gov has very nice views of everything that's going on right now. If you want stories, then nasa.gov/Earth Day had a whole selection of climate change related things, both in the technology sphere and in the partnership sphere and in the data that we're looking at. But one of the things that I think that we'll be recommending that we do very quickly is change that so that we would have you know, a kind of one-stop shop where you can go in, you can see the gamut of things that we're doing, where, you know, then we would kind of point people to the people that are actually doing the work, but really kind of bring all those things together that we're bringing in right now in our working group, but like making sure that that's much more visible to everybody.
All right, thank you very much. So that's all the time we have for questions today, and thank you very much, Gavin. I actually learned a lot on that, and I enjoyed it. I'm more respectful for the things that you guys are doing after hearing you. So thank you.
Thank you.
So we're ready to go to the next session towards climate solutions. Go into your app that you're running and click here to watch the next session, or go to the menu and click the session on climate solutions. And this is Alan DeLuna signing off for the moment.